Hi and welcome to JAX London. I've got Jessica Deen with me today. Hi Jessica.
Hi.
How was the panel? It was about cloud native, right?
It was awesome. A lot of fun to be a part of.
And how was the audience? Did they interact with you or?
They were very interactive. They were actually further along in their cloud journey than I had anticipated, which was very awesome to see. It shows that progression and that momentum and comfort kind of becoming more prevalent.
So you already discussed this, but let's recap. Cloud native is more than just a buzzword. But people don't really understand what it's actually all about. So how would you define it?
I would say it's a series of, there's a lot that goes into it. Like a lot of cloud native practices or methods are built on top of what I would trace back to DevOps practices. But the short of it is that people have heard of loosely coupled applications, microservice architecture. But one of the reasons why microservice architecture and like various like modular APIs are so successful is because it's kind of built on, again, these DevOps practices of infrastructure as code, repeatability, being able to recover in the event of a failover, so automatic failover, logging, telemetry, all of these methods and practices really kind of set up this new ubiquitous like 2020 cloud native kind of era that we're drifting towards at a very fast rate. So that's more than drift, but like moving very quickly.
And how exactly can cloud native shake up the traditional workflow, let's say?
I think it already very much so is. Anybody who's already using cloud-based infrastructure or taking advantage of maybe a more modular approach to their infrastructure, as opposed to delivering software maybe every 6 to 8 weeks, you're now delivering several times a day, whether that's 6 to 8 times a day or 100 times a day. You're able to have more of a liquid software kind of delivery approach, as opposed to, again, it's a lot harder to make an application change when you have something that's a monolith. And then it's even harder when you have your infrastructure maybe on-prem and you're trying to roll out a change and you have to go through change approvals and it works in dev, it doesn't work in QA, it's not the same in each environment. So cloud native and using cloud native technologies or cloud-based like container orchestrator tools, because I do believe containers are a huge part of cloud, that really sets you up for being able to have that repeatability, that failover, the automated recovery. There's so many benefits for starting to roll over into that's really why the cloud is kind of shifting away from the more traditional sense.
I see. And since this is a Java conference, I have to ask, why would Java developers, for example, go down the cloud native path?
So, I mean, I think that when you're talking about cloud native, it's not specifically tailored to any particular developer. The answer is going to be the same for Python, for Go, for Ruby, or any other language. But I think the one thing that really strikes me about Java is, I think every Java developer knows your dependencies and your application architecture, everything is so specific when it comes down to Java. And your packages and your requirements are quite larger than maybe other languages. So when you are trying to recreate that from a dev environment to a QA or to prod, you're trying to make something that's more immutable and portable. How can you do that when you want to make sure that your Java versions or your JDKs or whatever are perfectly aligned for your dependencies? That's where cloud really kind of comes in, and taking advantage of the newer infrastructure simplifies the Java's, I guess, after development kind of process. So after they've written it, after they've tested everything on their system and checked it in, and they think, I'm done, they're not usually, especially in the event that you try to now move it onto a different server and then somebody else comes back and says, hey, the code's not compiling, what's needed? How can you kind of solve some of your bottlenecks and some of your pain points where your process literally has to stop because of whatever problem? So cloud really kind of helps speed that up, specifically with, again, using things like Docker and Kubernetes and some of these more cloud native tools.
Mm-hmm. And what should Java developers learn or forget, depending on the situation, in order to make their code more cloud native compliant, for example?
I think the big thing is being comfortable with change. A lot of Java developers, for rightful reasons, are maybe a little bit more conservative, and they've been doing things a certain way for a decade and a half. But our industry, our technology state is changing, and it's changing at a drastic rate. We're moving faster than we ever have before. We have companies that are spinning up that are younger. We have more and more devices online. as developers or ops, right, people who work in technology, our goal is the same. We want to deliver value to our customers. So if you can remember that as the core principle and not whatever hard and fast, tried and true technology you're still married to, and remember why you're married to it or what your ultimate goal is, and focus on that delivery, then you'll be a lot more flexible in your development, a lot more flexible in your learning, and being more comfortable with adapting to a new tool set.
And there are, of course, a lot of technologies tied to this concept. What are the most important technologies and that should be part of, I don't know, a developer's cloud native strategy?
I think maybe not necessarily technology so much, but maybe more so of an understanding. Being aware that cloud and abstraction exists, container orchestrators, and actually in the panel, there was quite a few more hands that went up for Docker and Kubernetes and developers that are already using those technologies, which is great. So I think becoming more comfortable with using things like Docker, which helps, I mean, essentially when you think of what Docker is, right, it's not a Docker container, it's not a real thing. It's process isolation to deliver your application. So if you can start utilizing those tools, all the problems we just identified as far as it works on dev, it works on QA, it's not working on prod, or it works on my computer and it doesn't work when I check it in, those problems are solved. So then by me not having to stop and go back and debug and troubleshoot and figure out what dependencies are needed or what dependencies aren't needed, I'm able to increase my performance, increase my deliverability, make it faster for deliverability, and then I also increase my security, right? Because I don't have to install all these arbitrary packages that may or may not be needed. So I think definitely utilizing something that can encapsulate your environment, something like Docker, is incredibly valuable in every developer's toolkit.
And what's the most promising of them all? Would Docker be it, or one?
I don't think there is one, right? This space is still being defined, and so I mean, even down to Kubernetes or serverless or whatever. Everyone always asks, like, where should I park my time? Where's the future going to go? I think the future is still changing, right? And it always has been. I mean, you think back to 10 years ago, we were doing everything on virtual machines. People probably thought, well, this is the greatest thing because I don't have to build up physical computers anymore. Now I can have one computer that runs all these virtual environments. But while everyone thought that was the end goal, now we've abstracted it even further. And now containers is kind of the operating system virtualization. So I don't think Kubernetes is the thing. Kubernetes is just the thing that's going to get us to the thing. And then whatever that thing is going to evolve and change. That's one of the beauties about technology, right? It's ever changing. But I think right now in today's world is understanding how Docker works, how it can simplify your development experience, and why it's beneficial. So again, like for that encapsulation, that process isolation, being able to limit like hardware usage, your CPU usage, your memory usage, all of these are benefits. And so if you consider how that helps you, then as new technologies start coming out, you can tell, okay, this has already fixed this problem. Now these new technologies are addressing these other issues, and you're able to kind of continue on that growth path.
Mm-hmm. And you just mentioned serverless. Is it like the next phase in cloud native application development, or?
I think it's another component. I don't think it's another phase. I don't think it's a one-size-fits-all where serverless is going to solve every problem. I think in certain situations, serverless can make sense. I think in other situations, it doesn't. It's just another product and tool that can be used and leveraged if it meets your business needs.
Mm-hmm. And last but not least, are we already living in a cloud-first world, or are we not there yet?
I think we've been kind of in a cloud-first, mobile-first kind of world, right? I mean, we're at a time in society where everyone has multiple mobile devices at this point. You have an iPhone, you have an iPad, you have a Google tablet, a Google phone, a computer, multiple computers. So the average person now, you're having like multiple devices in your backpack at any time, or in your bag or your car or your house. And we're all connected to some sort of cloud, right? We all use social media, we all use networking, we're all texting, we're so reliant on it, where we've been kind of in this cloud world for a while. And as developers and even IT and ops, we now have to see how we can keep up with that momentum, with that growth, with this change.
Yeah.
Yeah.
Okay, thanks a lot for the interview, and have a nice time in London.
Thank you so much. Pleasure being here.